we go. I see the steam coming through. All right, this is our can. Completely crushed in. All right, so we have our can. And we filled it with a little bit of water at the bottom. When we put it on the burner or above a flame, we are adding heat to our can. And right now, we have a bunch of air molecules and atoms in our can, and they are filling up this whole space. What we know about anything that's in the state of a gas is that its particles are spread out far and they're moving very quickly. Now the thing is, there are also air molecules outside, and they're darting around the can, bumping into the can, just as the air molecules inside the can are darting around, bumping into the can off the walls, up, down, up, down. And the thing is, some of these air molecules, especially as this is getting hotter, they're going to move faster and faster and faster inside. They're zooming faster, faster, faster inside. And some are going to pop out of this hole. So we have air molecules that are starting to escape because they're moving faster, they're getting hotter, and so they're going out. But we also start to have, as a liquid heats up, we know that as we add heat to a liquid, it starts to change into a gas. So we're going to have water vapor molecules. It's just the gaseous state of water that are starting to fill up the air. Now, part of this is due to heat, that it's starting to fill up. As time passes on, there's mostly just water vapor molecules inside of our can, and outside of our can is air. Like I said, as our can gets hotter and the contents inside the can get hotter, they're going to speed up, and they're pushing and bumping into the can, exerting this outward pressure on the aluminum walls of the can. And the air around it as well is pushing in at an equal amount, which is why our can stays its normal shape. Now, what happens when we flip the can over and put it into our cold water is we are experiencing a rapid change of state. Our water vapor molecules are almost instantaneously changing into the state of liquid. So, at this point, we have the same amount of pressure going in against the can and from the can out, so that our aluminum is staying normal, as a normal can would look, not crushed, not imploding, not expanding, just completely normal. Now what happens is when we change heat so drastically, we're moving the can from a hot source to a cold source, our cold water. So we're gonna move our can and flip it upside down. And why we flipped it upside down is that the top will create a seal over this hole against the water. Now, by doing that, we're making sure that none of those water vapor molecules can escape out the top as the air molecules have. So we flipped our can upside down. And over here, there's still the same amount of air as over here, so I'll draw it in. And that air is exerting, it's pushing that same amount on the can as it always has. However, when we experience that rapid change of state of the water vapor molecules from a gas to a liquid, it happens almost instantaneously. So instead of having all of these water molecules over here, they're going to condense all together, which means to come together. They're going to condense into just a few large water droplets in liquid form. Now, what you can see is that there's all this empty space inside of the can, where all of these particles used to be bumping up against each other and pushing outside on the can. Now there's all this empty space where there's not molecules anymore. What's going to happen, and what you do experience in this experiment, is that all of the air outside of this can that's still pushing in, it's still pushing in. But the water droplets inside don't have the same capacity just because of their sheer size to push out, which is going to force our can to implode because the air pressure from outside is pushing so hard. We know air is super strong that it will crush the can. And there we have it. Air is pretty fantastic. If you want to try this experiment at home, your first step is to ask permission from an adult because you're dealing with hot things. Then gather your materials. Protective eyewear. If you don't have scientific goggles at home, you can use sunglasses. If you have real glasses, excellent. You need an aluminum can, a bowl of cold water. It's important that it's cold. And my favorite, tongs. So you don't grab a hot can with your hand. Metal is a conductor. It will conduct the heat and you will get burned if you touch the can that's on your stove. All right, so you're gonna fill just a teeny tiny bit of the bottom of your can, about 100 milliliters if you can guess about how much that is. I like to just guess based off of the weight. I feel like the water is covering the bottom enough, and it's not very heavy, but I can feel like it's a little bit of a thick bubble of water on the bottom, then I know I have enough. If you have not gotten permission yet, this is your step that you need to get permission because you are using a hot kitchen appliance. You will place your aluminum can with a little bit of water in the bottom on your hot kitchen appliance. Turned my stove a little bit hotter than medium hot, not the hottest it can go, and I'm going to place my can in the middle. Ooh, my hand is getting hot in there already. And I'm going to leave it for about 2 minutes.